In this video, we are going to see how to solve this one of the book back question, that is 3.11 from 12th NCERT Chemistry, Chemical Kinetics. Here some of the results of these reactions are given. The question is determine the rate law and rate constant for the reaction. To find out the rate law, first we need to know what is rate law. Rate law is the expression in which reaction rate is given in terms of molar concentration of reactants, with each term raised to some power, which may or may not be same as the stoichiometric coefficient of the reactant species in a balanced equation. In this question, balanced equation is given. For this, first we have to write the rate law. Rate law or rate is equal to rate constant into concentration of reactant A to the power m into concentration of reactant B to the power n. In chemistry, concentration term is always expressed within the square bracket. So rates equal to K into A to the power, that is square bracket of A to the power m into square bracket of B to the power n, where m is the order with respect to A and n is the order with respect to B. To find out order of the reaction with respect to A and B, we can consider any two of these results. Here I am going to consider the first and the second experiment results. The first experiment results can be written in the form of rate law, that is rates equal to K into, that is rate constant into concentration of A to the power m into concentration of B to the power n. Then second value we have to convert. For this, this power should be same. So 7.2 into 10 to the power of minus 2 can be written as 72 into 10 to the power of minus 3, which is equal to rate constant into concentration of A to the power m into concentration of B to the power n. Next, we change this 72 in factors of 6, that is 12 into 6 into 10 to the power of minus 3 is equal to, here also we change the 0.3 in term of 0.1, here also 0.2 into in term of 0.1. So now we can cancel this 6 into 10 to the power of minus 3 and 0.1 whole to the power m, k value, and 0.1 whole to the power m. The net result is 12, that is equal to 3 into 4 is equal to 3 to the power m into 2 to the power n. By using law of exponent, we can compare the same basis values, that is 3 is equal to 3 to the power m. So m value is equal to 1. Similarly, we can compare 4 and 2 to the power n, because 4 is the factors of 2. So 2 to the power 2 is equal to 2 to the power n. So n is equal to 2. Now we got m and n values. Substituting this m and n values in this rate law equation, we get rate of this reaction is equal to K into A to the power of 1 into B to the power 2. Next, we have to calculate rate constant value. We know the rate law equation, that is rate is equal to K into concentration of A to the power 1 into concentration of B to the power 2. Rearranging this equation, we get rate constant, that is K is equal to rate by concentration of A to the power 1 into concentration of B to the power 2. Substituting A and B values from any one of these experiments, we get K value, that is rate constant value. Here I am going to substitute first experiment results. Simplifying these values, we get 6 by 1 is equal to 6. Next, we need to find out rate constant unit. For this, we have to substitute a rate and a concentration of A and B in rate constant equation. We get this one. Simplifying this units, that is cancelling this liter and moles, we get mole to the power minus 2 liter square per minute. This is the unit of rate constant. Here also we can convert this value in terms of molar concentration. That is, molar concentration is equal to mole per liter. Here we have to change this mole value so that we take reciprocal of this molar concentration. We get m to the power minus 1 is equal to mole to the power minus 1 liter. Squaring this value, we get m to the power minus 2 is equal to mole to the power minus 2 liter square. Instead of this values, mole to the power minus 2 liter square, we introduce molar concentration power minus 2 into per minute. So we got already K value as 6. So rate constant for this reaction is 6 into molar concentration power minus 2 per minute.